Hello, what's up guys? In this video I'm going to introduce you to one of the coolest new features of Simulink about MavLink interface. It actually enables you to literally equip any hardware you have or any simulation you have in Simulink to MavLink interface. So it will let you to visualize, communicate, and send command and receive data from your model or custom drone, or even improve your already MavLink interface with pixels. So without further ado, let's get into it. So what is this MavLink? Let's briefly overview the concepts and definition behind it, so then we are all on the same page. MavLink, or Micro Air Vehicle Link, is an efficient, lightweight communication protocol. It's just a bunch of messages and data that communicates between drone, ground station, and also other drones or any other nodes in between this communication. Usually people think that the MavLink only let the drone communicate to the ground station and that's it. But MavLink is all the data that is coming out of the drone or going inside the drone. So if your drone is a part of a swarm, so the drones could talk with each other, they are using MavLink to communicate. If you have multiple ground stations, again you are using MavLink. If you have companion computer that sends off-board control data to your flight control, again you are using MavLink. Quite possibly you are using MavLink. Maybe you are using some custom protocol. But what is very good about MavLink is that it is reliable, it's error prone, it's very efficient. You can send different kind of data with different rates. For example, you can send one of the data at 100 Hz, another at 1 Hz at the same time. And not only you are receiving telemetry data from drone, at the same time you are sending commands to the drone. You are sending mission planning control, you are sending commands, you are sending errors and logs, everything using the MavLink. So that's the power of MavLink, that it's reliable, it's prone to any kind of errors, and it's well known for its reliability in UAV industry. But it's not only limited to UAV. You can implement it in your simulation. You can, if you are a researcher or you are a drone developer that you have created an autopilot for yourself, or just created a model of a quadcopter or any kind of robotic application. Inside the Simulink, you can now equip it with MavLink interface without any headaches, just like old days. You only need to use the UAV toolbox and the tools I'm going to introduce you in this video, and then you can visualize your data, send command to your drone easily and reliable. MavLink packet basically is an ordinary packet that is being sent over serial interface such as UDP or serial communication. At the first glance, it just looks like an ordinary serial packet that's being sent. Just like our old school, you should basically remember that we used to create some packets sending data from Arduino to PC, from PC to another PC. We all remember the headaches that we had. Some of the data packets were being missed, some of them will be conflicted with each other, some of them would be corrupted. We used to create some checksum. All those headaches are being fixed in the most reliable fashion with MavLink. As you can see in this example packet, there is a payload. Payload is what we are looking for. For example, let's focus on the attitude. We want to send the attitude of the aircraft to ground station. So the payload would be something like roll, pitch, yaw, and so on. The message would be something like the title of this payload. It would be, for example, attitude. Then we have a system ID and component ID, which is identical to the ID of the drones that we are sending data from. Then we have the length of data, the sequence, the checksums, and all other engineerings of data structure behind it. What is more interesting for me about this MavLink frame is that many of these MavLink frames are being sent and received at the same time. For example, you are sending the attitude data with this MavLink frame 10 times per second, and in the meantime another MavLink frame called, for example, heartbeat is being set at 1 Hz, and none of these data are being completed. They are independent of each other and they are communicating with ground station and other nodes. And what makes it even more crazy is that in the middle of all these communications, for example, you send a command, a flight mode change to your drone. In that case, none of the receiving frames would be interrupted, and in the meanwhile you are going to send another packet to the drone this time with the same structure, but the message is different, the payload is different. This would bring us to the next concept, which is MavLink Dialects. So what is Dialect? Dialect is a guide, is a documentation of all the message definition that we have defined. As I told you, MavLink is not just PixSite. MavLink is not just Autopilot and PX4. You can create your own MavLink messages for your own specific drone or simulator or model in Simulink and send data to it and receive data. But both your nodes in receiving and transmitting side should know about your message. They should know that if you say my message is a type of attitude, it consists of 3 single variables, for example. So you should define the messages and you should let the drone know how to send the data and what to expect from the commands and data are being sent to it. This is called Dialects, the message definition tailored for the specific system or application. All the documentation and different kind of dialects are available in the MavLink documentation page. You can open it and use the references and find the messages that you want. The most common one that we're going to use is the common dialect. But for example, for a specific application, the PX4 architecture, they have some specific MavLink messages for their own projects. So their dialect is different and Autopilot dialect is different. And even when you are using PX4, you may use different dialects. For example, if you are sending over a high latency radio frequency telemetry such as RF radios, you might want to reduce some of the messages update rates or just don't send some of the data. So you're going to use another dialect such as minimal. So this is the concept of packets and dialects. We don't want to go deeper on this topic. I just wanted you to know the data structure engineering behind it. What makes my tutorial in 2023 different than my last tutorial before 2020 is that this time we're going to use UAV Toolbox, which is created for Simulink. Before 2020, if you have remembered or you have watched my tutorials, I had created a YouTube tutorial about how to decode MavLink packets from a drone inside the Simulink. We use S-code functions and custom functions to decode. That was a very great method in 2020, but now in 2023 all of those headaches and complexity are solved and it's now behind the scene. You are going to use the blocks of MavLink connectivity in Simulink UAV Toolbox and do all of them in a modern way, more efficient and easier way. If you already have Simulink UAV Toolbox or your university has already purchased it for you, go ahead and use this and implement it on your projects to improve your project. Many of the subjects here, such as UAV motion planning or UAV scenario simulation or some of the object avoidance applications of the drones, are very complex. For even an expert, an advanced engineer, it would take weeks or months to develop. And all of them right now is ready to use for you. All you have to do is to follow the documentation and use examples to understand how they have implemented, and you implement it for your project. So go ahead and use Simulink UAV Toolbox and just explore the possibilities you can have with this that you didn't have a few years ago. Okay, let's review what we're going to demonstrate in this video tutorial and why we want to create custom MavLink packets. There are many applications that you might need custom MavLink packets. I already mentioned some of them in the last slide, but it depends on your own applications. In this video, just for a demonstration, I'm gonna assume that you have a model of the quadcopter, which is very common with the researchers. They have created some advanced models of their drones or robots in maybe new algorithms or maybe nonlinear simulators, and they want to visualize the drone inside the QGroundControl or any other MavLink-based applications. You can easily, without any application, without any coding, just use the Simulink to send your data and equip it with MavLink interface. This is what we're gonna do today. We're gonna connect our model to QGroundControl, and QGroundControl assume that another drone is connected to it, just like an ordinary PixSite drone. It can be another ground control session as well, such as Mission Planner or any other ground control session out there. There are some other applications that you want to you may need custom MavLink packets as well, such as communication layer between the drones and the station. For example, if your drone is part of a swarm or drone show application, maybe you want your drones to communicate with each other or share their trajectory with each other. In that case, you might need some MavLink, custom MavLink packets that send between your drones. Or you might need some custom data. You have a specific sensor on your drone that you want to send the data to the ground station. You might need a custom MavLink package. Or maybe you want to interact your drone on simulator with Simulink. Or maybe you have created some special commands and you want to send those commands to your ground control session. Remember, you could even create some modules for your PICSOC as well. If you have followed my last tutorials, I've already demonstrated how you can use the Simulink support package for PX for autopilot. So if you have a custom PX4 module inside your PX4, then you might have some custom dialects, custom MavLink messages that you want to use. So these are just some few mentions of application that you might encounter, but it depends on your application. Now that we know the basic concepts about MavLink interface, let's go ahead and create our first Hello World application with MavLink interface in Simulink. Make sure you have UAV toolbox for Simulink installed and activated in your Simulink. Next step is to download my plugin from the MathWorks add-ons or search in Simulink MathWorks file exchange and search for Simulink MavLink communication demo. You can install it easily from within your MATLAB or manually go ahead and search it in MathWorks file exchange and download the zip file. Or you can also download it from my GitHub repository. Download the zip file and extract it whenever it's suitable for you and open the folder inside your MATLAB workspace. Once you've opened the folder, you will find these two files, Hello World and multiple rate example. Go ahead and open the Hello World, which is the most basic application possible to have our first MavLink communication. This is the most basic application that serves as a Hello World here. We're going to create some dummy variables here, some most common variables such as time, altitude, roll, pitch, yaw, latitude, longitude, and GPS altitude. And we're going to mimic an artificial drone here. We can change the data, for example, change the roll here using these sliders. But in real application, these items would be created by your simulation model or your hardware or any other application. Here we're going to just imagine that we have a drone that has some roll angle and pitch angle. Then we are going to create the MavLink packages inside this subsystem. Here we have created 4 MavLink messages: attitude, altitude, global position, and of course heartbeat. Heartbeat is the heartbeat of your MavLink interface, which is very important. We're going to review how you can create some add-ons or custom MavLink messages here. To create a MavLink message, first you need to create a MavLink blank message here. It's very easy with UAV toolbox. All you have to do is to search for MavLink blank message and open it. Here you should select the dialects you want to use. As I told you in the slides, you can create your own XML for your own dialects or just use some common ones, and the most common we usually use is a common.xml. Once you have selected the common XML, go ahead and select your MavLink message type. For example, you can select attitude, altitude, and so on. We're going to select heartbeat. System ID, we usually put 1 here, but because I'm going to connect more than one drone here, I've selected 2. If you have more than one drone, each drone should have an identical code. The next step is to use this message and serialize it. When we didn't have the UAV toolbox option, we had to manually create this for our purpose. But here it's just a matter of click. We're going to click MavLink Serializer and all the headaches will happen behind the scene. So open the MavLink Serializer. Again, you have the option to select the dialects and the MavLink message. That's it. You say that I want to create the MavLink heartbeat here. And that's it. Your MavLink packet is ready. Most of the packets are not just simple like the heartbeat. Usually we want to add some data to the MavLink. In that case, we're going to use the bus assignment block, and we're going to put the bus assignment somewhere in between the blank message and the serializer. Now we have the option to add whatever payload we want to the MavLink message. We're going to refresh it and the payloads are available here. These payloads are identical for the MavLink heartbeat message. It's going to be different with any other MavLink messages. Let's select base mode. Base mode actually defines the flight modes that the drone is already in. So select the base mode, and now we have an option to manually assign a flight mode here. Let's connect a constant, and what value we should be inserted. In that case, we're going to use the MavLink documentation in the common.xml dialect and search for base mode. As you can see, base mode is a part of the heartbeat payload. Here it is. The heartbeat ID number is 0 and the base mode is actually an uint8, is unsigned integer, and it's a type, it accepts the mav mode flag enumeration. And then you're going to search for mav mode flag and you have different options here. Let's enable the stabilize mode, which is the value 16. So we had to manually assign 16 to the payload. And then our drone should think that it is in the stabilize mode when it initializes. And that's it. We're going to put a rate transition here as well, but I'm not going to cover this. In the next example, we're going to cover the multiple rate as well. But here we don't care about the rate. Just put a rate transition here. And remember that you might need to add a data type conversion here because we're going to use single here. But by default in Simulink, all the constants are blocks. Just the same process for all other things, the altitude, attitude, and so on. For example, for attitude, you can see the payload is different. It has roll, pitch, yaw, roll speed, pitch speed, and yaw speed. Again, update the rate transition for the sample rate as inherited for all the blocks as well, because we don't care about the rate in this example. And then we're going to mux all the packets together, and at the end, our UDP packet is ready to be sent. We use the UDP send block here. The remote address will be our local host. If you want to send it to another computer or your drone is not virtual and it's a real drone, you want to send data to a hardware, put a hardware IP address here, both for the local and remote address. Now, here I've selected the local host. Port number is any port number that you think. I have selected 14550, which is the default one for the QGroundControl, and QGroundControl will automatically always listen to this port number. So if you select this port number, QGroundControl will automatically connect. Let's test our application. I'm going to open the QGroundControl here for you and also run my simulation here. We expect to see the drone appears on the map on somewhere around west of Iran by the dummy latitude, longitude I have selected here.
Stabilize flight mode.
And as you can see, it's working. QGround thinks that it is connected to a drone. It is on a stabilized mode. You can see the roll, pitch, and the position and the altitude are exactly the same ones that we have selected. Let's change the position to the Mehrabad airport position. It is 35.69 for latitude and the longitude is 51.311. Let's add it here and see how our drone position changes. Remember that the values inside the MavLink messages is not with decimals, so you have to multiply it by the power of 10 to power of 7, so it will be an integer overall. Let's change it, and we expect the drone position to suddenly change its position. As you can see, it happens. Now it is somewhere else. And let's update the latitude as the longitude as well. I forgot to add the decimal here, and now we are in another part of, I don't know where it is, I have no idea, somewhere else on the board. Let's update the value. Okay, now we are exactly on Mehrabad International Airport in Tehran. So this is the most basic application that is possible. You can change other items as well here if you like. For example, let's change the pitch, and as you can see, the attitude indicator is changing in real time. And the roll also changes, and you can also change the altitude, mean sea level, and the corresponding altitude would change. In real application, these values are being changed in real time by your model simulation. You can stop the simulation, the communication would stop, and again,
Communication lost.
And everything will continue.
Communication regained.
If you analyze the data, you want to analyze the data, go to Analyze Session or MavLink Inspector. You can see right now all data are being sent at the maximum rate that is being set in the mux block, which is 5 Hz. So all the data are being sent at the same rate, which is not efficient. We don't want to send the heartbeat at 5 Hz. We want to send the attitude at maybe 5, 10, or maybe 100 Hz, but the heartbeat at 1 Hz. So in the next step, we're going to use the other file, which is multiple rate transition, and try to send data in a more real fashion. We want to send them with different rates. This is basically the same, almost the same example that you had before, but with some consideration for the variable rate of transmission. Let's enable the multiple rate transition overlays. Okay, as you can see, Simulink has created some color legends for me that is showing that, for example, which blocks are fixed step constant rate and some of them are multiple rate. You can see the green item, the dark green is our heartbeat, which is 1 Hertz. The dark blue is our 0.33, it means 3 Hertz. The light green is at 5 Hertz, and so on. Now we are sending data in different rates. I have created a mask block for you that handles all the rate transitions and sending data consideration for you, ready to use. All you have to do is to just select the sample rate you want and it will do it for you. Okay, let's run it, and as you can see, we are now again in the Mehrabad airport. Now we are in pre-flight mode, and if you go to analyze section, you will see that now the heartbeat is being set at about 1 Hertz, attitude at about 5 Hertz, altitude at about 2 Hertz, and position at about 3 Hertz. And this is a much more realistic scenario. Okay, for just an extra fun part, let's do some
Communication
fun
lost.
things here. Let's try to move our drones and see how it will work. For example, let's change the latitude. We're going to create a sun block here. And I'm going to connect a ramp to the sun block. In that case, our aircraft is expected to go north and the latitude increase at a constant rate. Let's put the slope on something like 1%, which it means that at each second 0.01 of the latitude will be added. So our drone will look like going north. Okay, as you can see, it's going very fast to the north, just like a satellite. Let's add something more interesting to
Communication
the project, and this
lost.
should be the last extra fun parts here. If you have watched my last tutorial, I've demonstrated to you how to use WSL, Windows Subsystem Linux, and implement your PX4 software in the loop inside your Windows. Let's go ahead and open that. If you haven't watched that video, I will put a link for that, and you can follow the tutorial out there, and you have your virtual PX or PX4 flight stack on your Windows as well. Okay, now we have a flight control, a PX4 software in the loop that is actually a PX4 environment, and we're gonna connect it to our QGroundControl. But since it's on Windows Subsystem for Linux, first we need to find the IP address of this virtual environment. Again, if you have no idea what we are doing here, don't miss our video about Windows Subsystem Linux for Linux and create our software in the loop simulation. I've covered all these steps in the detail and informative in that video. Okay, the IP is 172.142.141.34. It's already assigned here. So right now our virtual PX should be connected to the QGround. And there it is. This one is somewhere in the virtual environment, something like, I don't know. It is Zurich. It's Zurich city, very beautiful city. Our software in the loop thinks that we are controlling a drone in Zurich, and now we're going to connect our custom drone as well, but with a different system ID. System ID is selected to be 2 here. And now we're going to run our Simulink as well. And now you should see that QGroundControl will tell you that another drone is also connected. As you can see, connected to vehicle 2. And now we are actually connected to 2 different drones in 2 different parts of the world. And we can analyze each of them separately. We can, for example, assign a command to the drone in Zurich to take off. And meanwhile, we can analyze the drone behavior in Iran as well. We can switch to the other drone here, vehicle 2, which is our virtual Simulink model of a drone here, and then we are focusing on the vehicle 2, and we can change the parameter here. For example, if I change the altitude here, you can see the vehicle 2 altitude would change. The altitude is changing. You can change the pitch, roll, and the meanwhile altitude 1 is hovering somewhere around Zurich. This is a very fun project. You can coordinate drone. If you are involved in a drone show or swarm project, you will find many vehicles here you can manage at the same time. Let's analyze the MavLink commands that we are sending and compare it with the Pix4 architecture and Pix4 MavLink messages that are being sent. Okay, here it is. This is the Pix4 MavLink messages that are being sent. For example, the attitude is being sent at 50 Hz, but heartbeat is being set at 1 Hz. You can see the same structure here. There is a base mode, there is a payload here, there is type, autopilot, and the same. Let's switch to our own MavLink interface. You can see again the same structure here, but we are sending far fewer data here and far limited data here. You can go ahead and create as many as data you want and be just like the Pix4 flight stack. Okay, that's it. I hope you have found it interesting and use this in your future project. And researchers, this would be the first video in this tutorial. Maybe I'm gonna create some other series in this tutorial about how to send data. Right now we just receive data, create our MavLink telemetry data, and in the same way we can send commands to our drone. We can send the flight mode change commands. Maybe in the next tutorial I'm gonna cover that. And if you don't want to miss those video tutorials, go ahead and like this video and subscribe. Let me know in the comment section if you have any question or you have any advice or comments for the next tutorials. Until then, have fun, good day.